we need to move ahead and look at the main method. We have already written a few programs, so this is not a topic that we need to do now. And we need to see what user inputs are. And after that, we will move ahead and actually look at what programming constructs are. So we need to look at how to write if-else statement. We need to also look at how to write the loop statements while and for. And in addition to this, we will also look at break and continue statements and range functions. So let me get started. Before we get started, anybody has any questions from yesterday's session? Okay, okay, perfect. Perfect. So let me get started then, right? So for Matplotlib, we have already covered till NumPy yesterday, right? And like I said yesterday, I'm just repeating myself so that you guys do not feel that this is very basic. We are going to look at all of these in much detail. Probably we'll need a full day to cover this NumPy, but then we are just taking a brief intro right now. Why we are taking a brief intro? Because all of these are very basic and core to Python, and no matter what you do, Python and NumPy is not something that you can ignore. So we needed a brief introduction how to get started with these concepts so that we can continue to work in them, and later on we are going to look at these concepts in much and more detail. So we have looked at Python. Yeah, sure. Sorry about that. Yes. So we have already looked at pandas, we have already looked at NumPy, right? The third one is, and again we are going to look at it at a very brief, is Matplotlib, right? So Matplotlib is a Python package that is part of Python core, and we use it to uh, create charts or create visualizations in Python. And these are very simple functions that we have available in Python. So when you look at Matplotlib definition, what it says is it's a comprehensive library for creating static, animated, and interactive visualizations in Python. And that is what it is. It is used for do any kind of a charting. So let's say if you have data available in a data frame, right, a pandas data frame, and you want to create charts out of it, then Matplotlib lets you create charts uh, using different functions that it has, right? And then the primary function that it has is plot, uh, df.plot. So we have already seen what our data frame is, right? Let me just quickly run this code again so that so yesterday what we did is we imported pandas and then we had defined a pandas data frame named df, right? And this is what our df was. This is what our data frame was, right? Now what we are trying to do later in Matplotlib is using this library to plot the information, right? So when we do this, df.plot kind is equal to bar, then what happens? It is plotting ID and age for all of the records, right? So ID, of course, we knew that we had put in ID value 1, 2, 3, 4, and 5, and then the corresponding age values for all of these rows. So whatever we had as ID and age values, it is plotting those values in a bar chart, right? So let me just print the value of df so that you can know. So the ID values are 1 to 5 and age values are 23, 43, 21, 20 and 15. And this is what is reflecting here as the orange bar. So orange bar, the legend says that the orange bar is for age and the blue bar is for ID, and this is what it is. If you look at the command, this is very simple. You just have to specify what kind of a chart it is going to be by specifying kind is equal to and then this parameter. If you're wondering as to how you can possibly plot another chart type, then what I'm trying to do with you here is letting you know what are the different possible values of kind is equal to that you can specify here, right? So for this, what you can do is you can, yeah. So this is a parameter. This is a parameter name. You can You can think of this as type. I'm trying to plot something. No, no, no. You cannot just specify anything. So kind is equal to is going to be the same, right? Yeah, this is a parameter keyword, right? The name of the parameter. What you can specify here is something that I'm just letting you know, right? So what I'm trying to do here is I'm trying to keep my cursor right after this opening brackets, right? Right? My cursor is right after the opening brackets, right? And what I'm trying to press shift and tab. So when I press shift tab, then it is showing me how to actually use this function df.plot, right? And I can actually expand this further. And this is nothing but the documentation which is available for this Python function that we can refer to and find out how to use it, right? So if you look at it, it says parameters, right? Parameters. What are the parameters? The first one says we can specify data as a data frame, right? So that's one parameter. When you look at the next set of parameters, it says kind. Kind is equal to str. Str stands for string, right? What kind of string we can specify? We can specify either line. So if you specify line, then this is going to create a line chart. When you specify a bar, then this is going to plot a bar chart. And that is what we have tried to do. When you specify bar, it plots a bar chart, right? We have already seen this. BARH is nothing but bar horizontal bar chart, and this is kind of very self-explanatory. If you have seen these chart types, because these are very basic chart types, right? I mean, the basic chart types are either a line chart, a bar chart, or a pie chart, right? These are the three basic chart types. So you can plot all of these by specifying these parameters. So what do you need to plot a chart? You need to know what is a chart type. So that is what you specify in this parameter. Kind is equal to. And what is it that you need in addition to what chart type? You need the data, right? Where is the data that you want to plot? And that is what you specify in this parameter, data. Now this is optional, and what you can also do is just skip this, right? We have not specified any data parameter, but then if you want, we could have done that as well. So why is this giving you an error? Because if you look at it, we have already specified this here, right? We have already specified this here, and there is no need for us to actually specify it again here. And that is the reason we need to skip this. And we did not have this at the very first place to begin with. So, although, yes, but then I just tried to make it simple for you guys. I'm just trying to let you know that ideally you should specify, but we are not specifying because this plot function, this plot function already knows what my data is. Why? Because we are invoking this plot function using the df.plot statement, right? Now, what is my df? We already know what is my df. This is my data frame. And data frame is nothing but, the tabular arrangement of this data, which stores the data in rows and columns. So this function already has access to this information. It just needs to know what kind of chart you want to plot. Let's say you change this. Now, the moment you change this to kind is equal to line, you see the chart type itself has changed. And that is the only thing you can change here. You can change the chart type to bar. You can change this to, yeah, sure. Yeah. So if you look at this, these are index numbers, right? Uh, these are index numbers. The value itself is represented by the height of these bars, right? So what is the ID value? The ID value is 1. And when you look at the ID bar, which is in blue color, it definitely is not 0. right? If it was 0, then it would not have appeared here at all, right? It is between 1 sorry, 0 and 10, and looks like it is 1. It definitely is not 0. What is appearing here is the index values, the 0, 1, 2, and 3, 4, the index values for these records. Sorry. Yes. Index number or row number. And row number or index number starts from 0 in Python. Every index value starts from 0 in Python. So if you have 5 records, it will be indexed 0 to 4. If you have 10 records, then it will be indexed 0 to 9. Right? Okay. So that is how you actually plot, right? Again, I'm just reiterating because we are not going to do this in much detail here as well. You just click on, you keep your mouse cursor next to the opening brackets, click on shift and tab, and it opens you the function definition, and you can just refer to this function definition from here itself and find out what exactly you want to specify here. You can look at all of these from here. So line, bar, horizontal, histogram, box, and everything is available here, right? What does a bar H do? It will just change the orientation by 90 degrees. That is it. There's nothing much which changes here, it's except for the orientation. Bar plots you the vertical bar chart. So that is what it is for the introduction of the Matplotlib. And what I have done is I've created an 40 to 45 minutes long video which you guys can actually look at. This is available on YouTube, and I'm going to put that in your dashboard as well. I may have, yeah, this is already available. So just look at this, and this has at least 10 to 12 different chart types, which you can actually plot in Matplotlib using Matplotlib, which is available as part of this tutorial. So when you open this, yeah. So when you look at it, this is going to be showing you all of these different chart types as well in much detail. So here we are trying to do a scatter plot, and we are doing box plot, violin plot. We are also doing some of these regression analysis using charts as well. So we are going to look at these still, but then not right now. What you can do is go through these on your own for now, and do let me know if you guys have any questions. Right. So with that, we are done with the basics of Matplotlib as well. And what we are now going to head towards is we'll look at what a main method is, right? So if you guys have done any programming language, I'm taking example of C, then what happens is, or maybe Java, right? So what happens in these two languages is you always have a main method, right? And main method is nothing but the entry to your program, right? The gateway to your program. So I'll let you know what I mean when I say entry or gateway to the program, and then we will look at the code. So I'm just opening a blank sheet here. Yeah. So let's say you're writing some lines of code, right? You have written, you know, a few lines of code, and I'm just drawing straight lines, but then think of them as these are lines of code, right? So this is your Python notebook, right? This is your Python notebook, right? And then you have written these lines of code. Now, when you run the Python notebook, what happens? The code executes from top to down, right? This one, the first line that you've written executes first, followed by this one, followed by this one, and it goes from top to bottom, right? And this is how it goes, right? But then ideally, if you are outside of this environment, you can write code in a much modular way or following more modular approach where what we can do is lines of code which are lines of code which are doing something specific, right, are grouped together. So you write a few lines of code in this code block, right? Now this is one IPY NB file, right? IPY NB file. This is one IPY NB file, right? Python notebook file. But inside this, whatever lines of code you write, they may be divided into multiple blocks, right? Now, what will be the reason why we will divide them into multiple blocks is something that we are going to discuss right now. And let's say this is our third block. So this is our third block, right? These are all my lines of code. Okay. So this is my, I'm just writing M1, but then this is my module 1. This is my M2 module 2, and this is my third module, right? Right now, even if in this case, right, first of all, let's first understand why would you want to not write the code like this? Why this is not the correct approach? Why this approach is desirable or why this approach is recommended? Ideally, you should not write the code like this, although even if you write and if it is giving you the correct outcome, then it is fine, but then it is not the preferred or recommended approach. Why we should write the code in modular approach is because it gives you a few advantages, right? This code is more readable, more structured, and every block of code, if I'm taking example of M1, then this is doing something very specific task. So what task this block of code may be doing? This may be adding a few lines, a few numbers, or it may be doing some addition operation. What this block of code may be doing? This block of code may be doing some transformation with the data, right? What transformations are is something that we will see later on, and we will be able to clarify more on this later on. But then think of this as if let's say there are null values in your data and you're treating for null values, then that is also part of a transformation. So what this block of code may be doing is some transformation, right? And what we may be doing here is EDA, exploratory data analysis. Now, if you look at the objective of these codes, they are entirely different, right? EDA is where we look at the data and try to, make some meaning out of it, or try to do some, generate some insights or analysis out of the data that we have. Transformation is something which happens before you can actually do your analysis, right? So this is a prerequisite for any kind of a analysis. If there are missing values, if there are nulls in your data, you need to first treat them. So this is a prerequisite. Now this is something where you are actually doing kind of a some kind of a mathematical operation within the numbers, or within the data that is available here. So does it not make sense to actually group them separately? It does. Why is that so? And how is it helpful? So in two ways, right? First thing is that the if you write these modules, the lines of code in different modules, then looking at these modules, you can very well say that this code is more structured, right? Or more readable. We know what is happening where. Although in this case, uh, it may be all top to down in the same order, but then this is not structured and not readable. The other thing is, if you write these specific set of codes in modules, then they all become reusable, right? We will see how to reuse them. Reusable. So what does it mean? When it becomes reusable, then any other program, let's say any other program, right? Any other program needs to, let's say any other program needs to do EDA, right? Then you do not need to actually specify or write the same set of commands. You can just call it here. You can just Yes, you don't need to. You don't need to write it again and again. If you need to do any same transformation which for which you have already written a module, then you can just call it here. Just call it. You can just call M3. You can just call M2. So what is happening here? You're calling means you're executing the same line of code which is already written in some other program, and you just need to rerun it. So this is the reason why we have uh, the concept, or why we have the recommendation that you should write different modules for different set of actions and not just write the code from top down. So this was the preface based on which we can now look at why we do have a main method. So again, we talked about different methods, right, inside a program. Now, what will happen is Python or any programming language by default, C, C++, Java, all of them, they have a main method, right? So let's say if this is a uh, .py file, right? If this is a .py file, then you should be able to define a main method here, right? You should be able to define a main method. So let's say this becomes your main method, and the name of the main method is main, right? M-A-I-N. So what happens is this becomes the entry point for your program, right? When your program starts executing, your program will start executing from the main method. And this main method is going to call the rest of the methods as and when required, right? So let's say this is your main method, this is your m1 method, and we have another method. Let's say we call it m2. So when the program runs, right? Let's say you execute this code, right? Or execute this py file. So you execute this. When you execute this, it is going to make an entry here, right? Because it does not know what M1 is, what M2 is. These are user defined functions, and it could be named anything. But one thing which is for sure is that it will have a main method, and it can make an entry from here. And this is why the name of the function itself is defined. You cannot choose for the main function, you cannot choose any other name. It needs to have a name as main, M-A-I-N. So when you execute the code, the program knows that since it has a main method named main, you want to start executing this module first. And chances are that this main method will have a few lines of code, and it will at some point in time call m1 method so that it executes this block of code, and it will also have call to m2 method, which means at this some point in time it will be calling m2 to execute whatever is written is m2, or whatever lines of code is written into m2. And this is what is the role of the main method, and this is how it will execute when you have main defined. Otherwise it is going to run top down. Clear? So do let me know if you guys have any questions. Otherwise we will see the programming example of this. No? Okay. So let's look at the programming example for this, right? So like I said, the name of the method is going to be main itself. And what is it that we are trying to do here, right? We are defining the main function. And just for simplicity, we are not doing anything here, not doing anything fancy here. We are just defining the name, the main method, and inside this we have just specified a print statement, right? Which says this is my main method. And how do we call the main method? By specifying the name of the function, right? Any function that you need to call, you need to specify the name of the function, and then to signify that this is a function, we have to, after the name of the function, specify a small opening and closing brackets. And this is very simple. I think we have already seen a few functions or called a few functions. It's just that we never called out that they were functions, right? So what is it that we are calling here? We are calling the plot function, right? Or the plot method, because plot is followed by an opening bracket and a close bracket, small one, right? let's look at some other part of the code. What is it that we are trying to do here? np.array, right? So which means that NumPy has a method named array, and that is what we are calling, right? Because just after array, what is it that we see? We have a small opening brackets followed by small closing brackets, and then there is some parameter that we are passing to this function or method. What else we have seen, right? So print itself is a function, right? Look at it. If you just remove this, print is nothing but a function, right? It is a function that does something for you. What does it do? It prints whatever you want to print on screen, right? So all of these are predefined functions or methods that we are using, right? What we are doing right now is trying to define a function for ourselves by using def command or statement. So this is the function, or this is the statement using which we define any method, and this way we can also specify them or define the main method. To call the main method, this is kind of a standard syntax. Whenever we need to call the main method, we first need to check whether the main method is defined or not. And to check whether the main method is defined or not, we need to write this statement. If name is equal to main, then call main. Otherwise, main will not get called. We are also going to look at if statement today, so it will become very clear as to how this is executing. But this is a very simple implementation of uh, main method where I have defined main, and you see nothing has happened, right? Because we are just specifying what will happen when the main method is called, right? We are not calling main method. Here we are checking if the main method is defined or not. And if the statement turns out to be true, then main method is going to get called. So when you run this, it says this is my main method, right? Now, how is this getting printed? When main method is getting called, the control passes on to here, and it is going to execute all the lines of code inside the main method, and we just have one line of code which says this is my main method, right? So again, going back to this example, what is happening when you are making an entry to main, then all the lines of code are getting executed there. I'll just extend this example so that you will know or have more clarity as to how this main can call another method, right? So what I will do is I will define another method, right? Let's say add, and print a is equal to 25, b is equal to 35, and here I'm just going to print a plus b. So this is another method that I've defined, right? Define a method named add. I am defining two variables in there, a and b, and then I'm printing the sum of both of these. Now, how can I call this? I can call this from the main method, right? And I can call add. So what will happen? Let me first execute this code and I'll show you what is happening here. So see, I've executed this, but then nothing shows up here. This print statement is there inside the main function, but then it is not giving me an output because we are defining a function, right, named main, and there are two things that we are trying to do. We are defining that whenever main is called, then execute this print statement, and after this call the add method. These are the two lines of code as part of this. This is not executing right now. This is being defined, right? And that is why we do not have any output here. Now, what is it? Since we have brought in another method, add in picture, we will need to define add as well, right? So this is how we are defining add. We are defining two variables in there, and then we are defining specifying a print statement. So let me execute this, and again we have a print statement here, but then if you look at it, there is no output because this code is not executing right now. This function is getting defined when we execute this code. When this will execute? When we call this function, right? So let's do one thing. Let's execute this code now and see what happens. So what happened, right? When we executed this code, it will first check if there is a function named main or not. So since we have already defined main, it knows that yes, this condition is true. There is a function named main, right? So we are calling the main function now. So what will happen? If you look at this example, your program made an entry here, right? And then this is executing each and every line of code. The moment it encounters any function call, the control will move to that function. The moment it encounters another function, the control will move to that function and come back again to main method. So we call main function here. So the control moves to this function. Now, this time what will happen is this is going to execute whatever is defined here. So first, it is going to print this statement, which is what we see here. And then we are calling the add method. So now the control will move to this line of code, this block of code, right? And what will happen here? We will define a is equal to 25, b is equal to 35, and then another print statement, right? So 25 plus 35, 60, and that is why, yeah. Yes, we will need to, na? Otherwise, how will it work? You will first need to define it, and that is what is happening here. Uh, the main function call is towards the end because if we put it over and above, then at this point in time when we are calling it, it will not know whether main exists or whether add exists. So we will first need to define all of this, and at the end of the code block, you'll need to actually call main. That is how it should be. So yes, you're interpreting it correctly. That is how it should be. And one thing which I kind of did not mention is the moment a function is called, right? Let's say M1. So M1 is called. What will happen when all of this line of code is executed? The control will go back to the main function, and then it will continue from the next line. So the next line is M2 is called. So control came back to M2. So what will happen? All the lines of code will execute here, and then control will again go back to the main method, and it will move on to the next line of code in main method. Since there is no lines of code now remaining to be executed, then the control uh, does not move anywhere, right? The program terminates because there is nothing else to be executed now. Clear? So this is how ideally we should be writing your code in modular structure. You should define things which are reusable, things which are doing specific tasks inside different modules or different functions, different methods, and call them to actually perform specific tasks. We are again, guys, like I said, going to look at how to define functions, how to pass parameters, how to return values from methods in much more detail. This is just an example. I've taken a very small example so that I can explain you what a main method is. That is the only objective. We have not covered what functions are and how to pass parameters and how to return values. These are all going to get covered again in much more detail when we look at this module on functions, right? So we have a whole module that we need to do functions. So we will look at it again in much more detail. So for now, this is just a small usage that we made. So that was for the main function, right? Now there is another very small topic that we need to look at, and this is how we use how do we use the keyboard, right, to take user input. And this is very simple, right? We have a function named input, and that is what we can make use of, right? So what I will do is I will just write this statement. Name is equal to input, enter your name, right? Maybe I'll just skip this as well. So this is a statement to take user input. When you execute this, what is happening? Our command was we are calling a function named input, and then we are specifying some text here, right? So what is happening? This text is showing up here, right? And then there is a text box appearing here, and looks like the program is still executing, right? It has a star mark over here. It is waiting for you to make any entry in here. So we can make our keyboard entry here, and we can just press enter. So what has happened? When you look at it, now the program is given me an output, and it says that I entered Manish, right? So this is how you can actually take user input, and what you can simultaneously do is, we already know that whatever we write on the right side of is equal to gets assigned to the variable on the left side of equal to. So we can simultaneously assign this to a variable, and the name of the variable could be name. So that is what we can do. After that, we can also print something using this variable, right? So what is it that I'm trying to do here? I'm trying to welcome the user who is entering his or her name, right? So let me execute this command again, or this code block again. Now again the same message, enter your name. I'll specify my name, and this time around this print statement is printing welcome this message plus the name. Where is name coming from? Whatever input the user is specifying, that is getting assigned to this variable name, and this is what is printing here, right? I can execute it multiple times, and every time I specify a name, this is going to welcome that user, because whatever input the user is making, that is getting assigned to the name variable. Yeah, let me do that again, and see, this is how it is. So taking user input is very easy in Python, and you can use this to enter anything that you want from the keyboard, right? You can specify numbers or special characters whatsoever. It is just going to take whatever input you specify and then store it into the variable that you are looking for. Now it is the responsibility of the user to enter these values responsibly, right? What I mean, enter these values responsibly is because if you're asked to enter name, then you better specify characters and not numbers, right? Because numbers would not translate into name, right? So although there is no validation check in here, but then if you really want to specify any validation, then what you can do is, we have already learned data type casting, right? So we can specify type casting to be able to do some kind of a validation. So if I'm expecting, let's say, enter your name and then uh, enter age. So age, enter input, enter your age. You are okay. I'll let you know how this statement is going to be different. But then what I'm trying to do is, we are going to show the user um, this statement which says you are dash years old, right? Or what is going to get filled in here? The value of the age, right? So let's say this is Raj, who is 10 years old, right? So what is the message that is being printed? Welcome Raj, you are 10 years old. So let's run this again, and let's now enter some text here, right? Now Python does not know whether you should be entering character or number. It is just going to take this as an input, and this is what it is doing, and it will just print it. But what you can do from your side is, you can actually typecast this into using int, and this is what we have already seen. We have seen this yesterday, right? Whatever value you are getting from the user using this command, right, or function, you can convert that into int using int. And if it will give you, if the user is going to give you text, then our int conversion of text is something That will be very interesting to look at, right? So let's look at it right now. So I specify Raj as name and then I specify a few characters in here. Now what is happening? It says invalid literal for int with base 10 dfhj. So it is not possible for us to actually make this conversion from a string to int. It can only happen when the number that you've specified here is stored as string, which is not the case. You cannot convert this text or any random text into int. You can only convert it into int if you have a value stored as text, which is not the case. These are all characters. These are not values stored as text. So this is not going to work. We will not worry about it right now. And the only thing which we need to actually take away is that Python is not going to handle this for you. You'll need to specify, and then the user will need to be using this responsibly, right? A new thing that we have seen here is how to print these values, right? There are two ways you could have written this statement, right? You are plus age years old is one way. So these two lines, right? This one or this one, they will give you the same output. It's just that if you write it this way, this is much more readable than this statement. What will happen here is this is going to print you are, then put in the age value and then years old. So this is essentially going to be you are 10 years old. Here you are specifying a placeholder. Now this placeholder will take the value from whatever you specify inside this format function. So if you specify age, then this opening curly and closing braces, right? This is going to get replaced by the age value, whatever you specify here. So let's run this one last time. And if you look at it, this print statement and this print statement is giving you exactly same output. So the choice is yours. You can use either of these. It is definitely not going to be a problem. You can use any of these. That is totally up to you. So with this, guys, the user input is kind of done. It is very simple. You just have one set of function to deal with, and you assign it to the variable. You specify the message that you want to show to the user, so that user knows what is expected for the user to enter, and that is it. That is how you take user input. So do let me know if you have any questions by now, and if not, then we will move to the next set of topics. Okay, sure. All right. So let's look at programming constructs now, right? So what we do in programming constructs is we look at primarily two things, right? How do we write conditional statements and how do we write loop statements? And these are additional concepts that we'll look at here, right? So why do we need conditional statements, right? So what happens is the program code that you write, right? It does not necessarily need to be. And for now, just for simplicity, I'm not taking any modular code example, right? I'm taking example of any set of codes which is written top to down, right? Just for simplicity's sake. So what will happen in your code, right? You are writing this line of code top to down, right? But then you do not want each and every line to be executed. This is not what you want. What you want is maybe execute this, execute this, execute this, and then if certain set of condition is true, then execute this line of code, these two lines of code, else execute these. So I want some condition to be tested, and based on that, either this will execute or this line of code will execute. They both will not execute at all. Either this is going to run or this is going to run. And That is what we achieve by writing conditional statements. So what will happen? What is the likely outcome? The likely outcome is that this line of code executes, this one executes, followed by these two lines of code. Or the other scenario is after these three lines of code, these two are skipped and these two run. But then one thing is given that in this case, either you execute these two lines of code or these two lines of code based on some condition, right? So what could be our condition, right? Let's say here at this point, we write one statement: if 5 is greater than 2, then run this, else run this. If you do this, or if you write the code like this, then what is going to happen? This statement is going to get evaluated, right? Now what is the outcome? The outcome of this statement is false. 5 greater than 2 will result into false. Now in this case, the control will straight away move to this block, which means this will not get executed at all. And like I said, either when the condition is true, then this line of code will execute it, and if the condition is false, then this line of code will execute it. And that is possible because we can write conditional statements inside Python using if statement, and that is what we are going to see right now. Instead of this statement, if you would have written, let's say 5 is greater than 7, then this would have resulted into a true, right? 5, no, sorry, 5 is greater than 3. Yeah, my bad. So 5 greater than 3. Then it would have resulted into a true. And in this case, the program control would have moved to then, and it will not then print whatever is there in the else statement. So we'll quickly look at this example here, right? And we will see what is happening here. So what we will now do is we will take variables as examples, right? So a is equal to 10, b is equal to 15. And instead of these lines, what we will write is a less than b, a is less than b, else a is greater than b, right? So what is happening? We are defining two variables, a and b, with respective values, and here we want to check the condition. Now we want to print whether a is greater than b or b is greater than a, right? But for that to happen, we will need to first check. You'll need to first check which of these variables are greater, right, than the other one. And we have already seen yesterday that we can, write these operators to do comparison operators, right? So what the first condition that I'm checking is if a is less than b, then I want to print a is less than b. If not, then the control will move to else block, and we will print a is greater than b, right? So let's see what is the outcome. So it says a is less than b. What is happening? This statement is getting evaluated first. And if this, like I said, if this statement results into false, the control moves to else. If this statement results into true, then the control moves to the then block, right? We do not write then specifically, but then this is the then block. So what is the outcome of this? A less than b. A less than b is true. What we can do is we can also print this, right? Print a less than b and see what gets printed. So a less than b is resulting into true, which means here this statement is resulting into true, right? And for true, this is going to execute the then block, and that is how the outcome is coming as a is less than b. Now, what can we do to print this statement? There are a few things, right? Let's change the value, right? Let's change the value. Let's make this 100. What will happen now? A less than b, No, A is not less than B, A is greater than B. So this will result into false. This will result into false. And the moment this results into false, then my control will move to the else block, right? And I'm assuming that this time, because the value of A is 100 and B is 15, the value of A is greater than B, it should print this line, right? So let's see. So this resulted into a false, and since this also resulted into a false, the control skipped this line of code and moved to else. So now we have this print statement which is printing A is greater than B, right? A is greater than B, and this is correct as well. Any questions, guys? Okay, all right. So good, sure. Okay, now let me let me do one thing, right? Let me do one thing. So guys, this does not make any sense for me to print A less than B, but I'm just leaving it here so that whenever you run this, you know what is happening here, right? And it'll actually help you to interpret this when you are running this code on your own. So I'm just leaving it here for now. And what we can do is we can just copy paste here and try to do something differently. So now I have changed the value of A to 15 and I've left B to 15, right? Now, what do you think is going to happen now? What will print? What will get printed? False, right? So since A is equal to B, A less than B is going to be false, right? In that case, your program code will move into the else block, and then this is going to actually print that A is greater than B, which is not the case. A is not greater than B, right? A is equal to B. So why is this happening is because our program has some logical error, right? This does not have a syntactical error. This has a logical error. We have only checked one condition, whether A is less than B or not. If A is not less than B, then it does not necessarily mean that A is greater than B, right? The third condition could be true as well, that A is equal to B. We are not checking that condition here. So in both the conditions where A is either greater than or equal to B, we are printing this only. So there are two ways we can correct this. Either you make this a statement correct, which is A is greater than or equal to B. If you write, then at least it won't be incorrect, right? It says that A is greater than or equal to B. This is one approach. The other approach is you can check for this condition specifically, right? And how do we do that? So we can write elif, which is else if, and we can write another conditional statement here. A is greater than B, then A is greater than B, else print A is equal to B. So what is going to happen now? If this is going to be false, then when the control moves to else block, then first another condition is going to checked here to get checked here. If A is greater than B, if A is not less than B, then is A greater than B? If yes, then print A is greater than B. And if this one is also false, then the control will move to else block where we are printing A is equal to B. Someone was asking something. Let me know. Yes, 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 yes. So, practically, it is very much possible that you may be required to check n number of conditions, right? So there is no limit on it. You can check n number of conditions here. And now, if you look at this program code, then it is going to give you correct result for any possible value, right? So let's test it out, right? When the values are equal, it is printing A is equal to B, right? I'm just removing this for now. So when the values are equal, it is printing A is equal to B. When my A is less than B, then let's see what the code does. It says A is less than B, and if my A is greater than B, then it says A is greater than B. And these are the only three possible values, right? Either the two values are equal or one of them is going to be greater, right, than the other. So in all possible scenarios, all the three possible scenarios, now this code block is going to give me correct result all the time, right? Let's check it out a little with maybe negative numbers. So we have 0 here and we have minus 15, right? So let's see if it is giving me correct results or not. So it says A is greater than B, which is correct actually. Uh, Minus 10 and minus 150. Uh, Minus 10 and minus 1.5. It says A is less than B. Is this correct? This is correct, right? So it is giving me correct values for all of these scenarios. You take positive numbers, negative numbers, whichever of them is greater or lesser does not really matter. So this is how we write more, uh, robust code if you need to do any conditional check, or if you need to actually, write code where part of the program code only executes based on some condition, right? Now, just to summarize this, right, what is happening here? You have written three print statements. Three print statements you have in this, block of code. But if you look at it, only one of them is executing based on whatever condition turns out to be true. So either this condition is true, in that case, this print statement will execute. If not, then if this condition is true, then this print statement will execute. And if both of these conditions are false, then this print statement is going to execute. At any given point in time, either two of these print or all of these print statements are never going to get executed. And this is what we meant by when we said conditional statements, right? Now the program code is going to get executed conditionally. This is not going to execute top to down where all the lines of code are going to get executed. All right, any questions with if not, then we will move on to the next set of topic. Okay, all right. So what will happen, guys, is that now onwards, you will need to do some practice, right? You'll need to build these logics where you are required to use operators. Required to do, assignment operations. You are also need to do, or required to do, or write programs which use these conditional statements. So expect some kind of a assignment or set of questions that I will put across in the dashboard here. Something that you guys should try and yeah. So it'll come down at this location. So expect something like this to be available by tomorrow, and you guys should actually try and solve them. Looking at this tutorial is going to be much easier for you, but then you got to really try and apply all of these yourself so that you know for sure that you have learned it well and are able to apply this yourself as well. That is where the actual test of knowledge will come into picture. So I'll put some starting questions in there and then just try to solve them. If you find any difficulties, you can always message, ask, or we can meet on Thursday to discuss some of these. So this was the conditional statement, right? Now we will look at loops. So right. So let's move to loops, right? So now why do we need the the concept of loops, right? So what happens is at times you may need to repeat something in your code itself, right? So let's say you need to print something multiple times, right? Let's say you need to print all the values from 1 to 10. So you need to print 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? How will you do that? Now, if you look at what is the program code that you need for this, you only need one command, right? Or you need to just call one function which is named print. Now, what will you do? There are two ways. You can write print 1, then just repeat the same code, write print 2, repeat the same code, print 3, and that ways you can write 10 lines of code which ends at print 10, right? Now, this is definitely not the smartest way of doing it, right? Because all that you're doing is repeating the same code multiple times, which is not ideal. If you need to repeat something, then you can actually use your loops for this, right? And how do we use loops? There are two ways, right? Either you can write a for statement or you can write a while statement, right? And we are going to look at both of these right now. So first we will look at a very simple example, and then we will come to printing 1 to 10, right? And this is something that we have seen earlier as well, right? So remember, we defined a list named fruits, right? How do you define a list? By specifying some variables inside or some values inside big brackets, right? So this was, let's say, apple, banana, and mango. Let's put one more item in here, cherry, right? So this is one list. How do you print all the values of the list, right? For this, we have already seen that how we can use for loop for this, right? There are ways to refer to the items within the list, right? This is going to be fruits 0. This is going to be fruits 1. This is going to be fruits 2, and this is going to be fruits 3, right? So we can write for items for item in fruits, we can print item, right? When we do this, then this is going to print me all the items one by one. Now, how is this working? We need to first understand this. The moment we understand this, then we can understand the rest of the for statements as well. I will try to write it multiple ways, right? So that it becomes easy for you. So instead of this, let me do one thing. Let me write another statement, right? And probably that is going to make it much easier for you to understand, right? For number in, and then I'm just specifying 1 3 5 2 4, print number. Now what is going to happen? I've just specified a tuple here, right? A tuple, right? This is a tuple because we are enclosing this into small brackets. We're going to look at tuples in much detail, but then we have already seen how to define a tuple, right? So this is a tuple. This list cannot change once defined. And what is happening here is when you specify for number in, and then you specify some kind of a list or a tuple or a range, then this loop is going to execute for each element within that list, right? So first, whatever is written inside this is going to get executed for the first item, then it is going to execute for the second item, for the third item, for the fourth item, and it will continue to execute till the time all the items in this list are exhausted. So which means that this is going to run 5 times because the count of the items in this list is 5. And that is why this is actually printing all these numbers. Now getting back to this example, what was happening? Instead of specifying all of these values here itself, we are taking the help of a variable here, right? A list variable. We are first defining the list and then we are specifying the list here. Now, if you extend this list by adding another item in here, then this is going to be executing 5 times. See, we are not doing anything in here. It is going to just print all the items within this list. And you keep extending the list and you don't need to change anything here. It is just going to run this print statement for each item in this list. And that is the beauty of loops, right? Let's add one more item in here and see what happens. Now it is even printing pineapple, right? So this is how loops are beneficial. If you need to execute a same set of lines, then you can actually specify them inside a loop statement, a for statement. Now, the thing to understand here is that how do we control this? Because whatever we specify here is the main factor which decides how many times the block of code within the for statement is going to execute. So for a list, it is going to be running as many times the number of items we have in the list, right? That we have already seen. So we kept extending the list, and then the loop extended to the total number of items in the list. Now this is going to happen for tuple as well. Let's say we add 10, we add -5, and then we add 100. See what is happening here? We are just changing or manipulating the list, and then it is actually executing these many times. Now we've already seen range, right? Range, what does range do? It will actually generate a list of numbers starting from the start number to the end number minus 1. So basically what range is doing is it is actually equivalent to me writing 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that is what is happening here. When we are specifying the range as 1 to 10, then it is actually printing 1 to 10. First it will run for 1, and then likewise it will run for 9. What is it that we need to do when we need to print 1 to 10, right? In that case, the only option that we have is change this parameter here, because it does not run for the last value. So if you want this to be running for 10, then you'll need to actually increase it by 1. You'll need to specify 11 here. So one more thing that we have already seen is we have already seen the concept of the step size, right? And which is the third parameter. And we had already seen that example earlier, right? The step size example. So what will happen in this case is we will start from 1, we will end at 10, but then the step size is going to be 2, right? So in this case, it will print all the values, but then the increment value is going to be 1, 3, 5, 7, and 9. One last example for this would be that we can even start from 10, go till 0, and specify the step size as -2. So basically what we are trying to do is we are starting from 10, ending at 1, because the last value is skipped, and then we are moving in the backward direction. We have specified a step size of -2. So it is printing 10, 8, 6, 4, 2, and the moment it encounters 0, this is not executing that, because 0 is not included. This is actually moving in the negative direction starting from 10 till 1, moving backwards. So this is how a for loop is used, right? You can use it with any list that we have already seen. We have used this with a list. You can use this with any tuple, and you can also use it with the range function, with or without a step size. So if you do not specify the step size, this is going to be equivalent to 1 in this case, right? So if you do not specify this, 1 comma 11 comma 1 is the same as 1 comma 11. So this is what it is for the for loop. Now one more thing which is what we need to look at here is the concept of nesting, right? And we will see that just right now. So what was happening here, like, right? Let's get back to the example of if, right? If my this statement was true, then the program code was moving to here. Otherwise, it was moving to here, right? But when you look at this statement, right, if and then else if and else, then if my this condition was true, then of course my program code was moving here, or the control of the program was moving here, but then here also it is not directly moving to the print statement. It is checking another condition, which means we have condition within the condition, right? We are checking one condition, and this is the primary condition. And if this is false, then actually we are checking another condition if this is true or not. Now, this is an example of nesting. What does it mean when we say nesting? So we have one condition. This is condition one. And if this is true, then we already know that this is going to get executed. But if it is not true, then in the else block, we have another condition. And then we have written a few statements, right? So we have another condition, which is part of the else statement. And this is what we mean by nesting. We are embedding another condition within the first condition. If my first condition is false, then I'm going to check for the second condition as well. And this is what means by nesting or condition within a condition. So we have already seen this with if. It's just that we did not specify that this is nesting of conditions. Somebody asked, right, how many lines or how many conditions we are allowed to check this way. You can keep nesting it to whatever limits or whatever requirements you have. There is no limit as such. There is no limit on nesting. You can, if your first condition is false, then you can check for another condition. If second is also false, and if there is a requirement, you can check for third condition as well. If your third condition is false, and if there is a requirement to check for the fourth condition, then you can check for fourth condition as well. And you can keep doing that till the time all of your conditions are checked. And that is what we mean by nesting. This is like dream within the dream concept, right? Like inception. If you Yes, simply put, this is what is called as nesting. You can do nesting of conditional statements, and you can also do nesting of the loops statements, right? And that is what we are going to see here. So how do we write nested for statement? So this is very simple. For I in range, let's say 1 to 5, step size of 1, let's specify. And for j in range, let me specify, what should I specify? 1, no, 2 to 5, step size 1. Or let me keep it simple. Let me keep it 1, 1, 1, 5, 1. Okay, what is it that I'm going to print, right? So I'm going to print the value of I plus j. That is it. So let's do a dry run first and try to figure out what is happening here, right? So what do you think? How many times this loop is going to execute? I in range 1 to 5. This is going to execute how many times? Four, four times, right? And then the value of I is going to be 1, 2, 3, and 4, right? How many times you think this uh, for loop is going to execute? So this one is also going to execute actually four times, right? Because if you look at it, this is 1 to 5, which means 1 to 4. Yes. So this loop is also going to run four times. But since this for Yeah, and then inside this for loop, we have a print statement, which is going to print the value of I and j. So in a sense, if you look at this this for loop, this is going to run four times, but then this is going to run four times for each value of I. So when you say that it is actually going to run 16 times, you are correct. You're not wrong. This loop is going to run four times, but this loop is going to run four times for each value of I, because this outer loop is also going to run four times. So this one is going to run four times, and inside this, every time this is going to run four times for every possible value of I. So let me clarify this, right? Let me take another whiteboard. So you have the value of I, which is going to, move from 1, 2, 3, and 4. And then you have inner loop, which is having the value of j. And then this is also going to move from 1, 2, 3, 4. And what you're printing is the value of I plus j. This is how it is going to work. Now, how does this work, right? First of all, you will start with the first value of I, 1, and then you will enter the loop here. And now, with the value of I as 1, the value of I is 1, you will run this loop four times with every possible value of j, which is 1, 2, 3, and 4. So now this loop is going to run four times with I is equal to 1. This is going to run four times because now there is a loop again, right? And then this is going to run four times. So when this statement executes four times, it is going to get executed with the value of I as 1 and j as 1. Next time I1, j2, I1, j3, I1, and j4. So what is going to be I plus j? My I plus j is going to be 2, 3, 4, and 5. So after this is done, the control will again go back to this statement. And now my I value is going to be changed to 2. And the control will again come back here. And with the value of I is equal to 2, my for loop will run again four times, where the value of j will change from 1 to 4. So the value of j will change from 1 to 2 to 3 to 4. So let's do that again. The value of I is going to be constant 2. The value of j is going to change from 1 to 4. So 2, 1, 2, 2, 2, 3, and 2, 4. And every time this statement gets executed, actually what is happening is 2 plus 1 is 3, 4, 5, and 6. So now you guys help me. What is going to happen now? Now again the control will go back to this statement. And now what is going to happen? The outer loop, yeah. So the value of I will be 3, and now the value of j is going to change from 1 to 4 again, right? So we will have a structure like this: 3, 1, 3, 2, and likewise, right? 3, 3, and since I have space, I'll probably complete this 3, 4. So this is going to be 4, 5, 6, and 7. And after this is going to be 4, 1, 4, 2, 4, 3, and 4, 4. So whatever the sum is, this is going to get printed, right? So now you know what is the concept of a nesting, right? In this case, for every value of I, this is going to run for every value of j. So now we've already seen, right? This should print you how many values in total? It, it should print you how many values in total? 16 values. Yeah, 16 values. And let's see. So it has printed me. Let me check some of these values first, right? So it should be 2, 3, 4, 5, and then 3, 4, 5, 6, right? So this is 2, 3, 4, 5, 3, 4, 5, 6, and these, and then we have 3, 1, 3, 2, 3, 3, 3, 4, then 4, 1, 4, 2, 4, 3, 4, 4, right? So this is what is happening here. So if we change the shape of it, let's say we change this to 3, then of course this inner loop is now going to run only for values of j, 1, and 2. So this one is going to run 4 times and this is going to run 2 times. So in total, this is going to run 4 into 2, which is 8 times, right? And then the values are going to change as well. So to be able to do this, guys, you should be able to do some kind of a, analysis on your own. We call this as dry run. And if you do this, then, on using pen and paper only, you can actually find out how the code is going to give you the output. And this ways you'll be more certain of how this is actually working and how this is going to give you an outcome. So this was an example of nested for loops. Think of this as something very similar to what we did in the if statement using elif. So moving on, what we will now look at is how to write the same program code instead of using for. How do we write this using while, right? So there is no compulsion for you to use for or while. They both do the same stuff. It is totally up to you if you want to use for or if you want to do while, right? At times, writing for loop is easier. At times, writing while loop is easier. So you can do either. That is totally fine. So let's see. Not really, not really. And I'll just give you an example as to how or where using while is preferred than for. uh, there are some conditions where writing while is more easier, and I'll just help you understand that. But then in terms of performance, there is no issues with performance. You can write for or while, they are going to have same performance implications. Neither of these is going to be slower than the other, if that is what the question is. So let's say we want to use for, sorry, instead of for we want to use while, right, to print the same thing, right? 1 to 10, we have done this earlier, right? 1 to 10, we have done this using a for statement. So instead of this, let me copy this, and what I will do is I will put this here as a comment for our reference, right? So wait. Yeah, so this is a comment, right? This line of code is not going to get executed. We are writing this just for our reference, and just we want to compare, right? So what is happening here, right? I have specified the value of I is equal to 1, and I've written I less than 10. While I less than 10, keep printing the value of I, and then increment I is equal to I plus 1, right? So let me simplify this. I is equal to I plus 1. So what is going to happen? Let me first execute this. So this is definitely going to print you 1 to 9. And if you want to actually make it work for 1 to 10, then actually you need to specify 11 here, right? Okay, so what is happening here? If you look at it, in the for loop, we were specifying the initial value, which we need to specify before while. We were specifying the end value, which is what we are specifying in the condition. Here, step size was optional. We did not specify this. But here, incrementally, the value of I is not going to change on its own. You'll need to do this yourself. There is no optional parameter 1 here. You'll need to change this yourself. So what is happening? If you look at it, syntactically, this statement is different, but essentially it is working the same way. In range function, when we were specifying the range function for the for loop, we were specifying all of these, right? 1 and 11 and 1, right? The start value, which is what we are specifying here, the end value, which is what we are specifying here, and then the step size is what we are specifying here. If you want to change the step size to 2, you can do that. Again, the output is the same. If you want to change the condition, make it 25, you can do that, and it will be the same as changing this value to 25. So ideally, you have a choice. You can either use for or you can use while. Now I'll tell you, there are different scenarios. Sorry, say that. Yes. So that is one thing, right? All of these were very simple here to specify. But yeah, but when you look at it here, you need to actually do this yourself, right? All of so this small code block is kind of getting broken down into multiple lines here. So writing, so you yourself are able to figure out, right, that this is much simpler to implement this code using a for than a while, right? And that is why I copied it over here so that you can make a comparison yourself, right? So looks like you guys are getting a feeling that writing for is easier, and that is true as well, right? A few places where you um, a few places where uh, while is helpful is when we actually do not know when to stop, right? Writing those statements are easier in while, right? So let's say you want to print the first 10 prime numbers, right? Now this is a little tricky, right? A prime number does not follow a fixed frequency, right? The first prime number is 1, I believe. The second prime number is 2. The third prime number is 3. But then the next prime number is 5, okay, and then 7. So it does not follow a trend, right? What do you want the step size to be? What can you keep the step size to be in that case? You really don't know. Plus, the other thing is that you will need to keep counting how many prime numbers you have encountered. And you also do not know where to end, because I cannot safely say that if I keep printing till or keep checking for prime numbers within 100 from 1 to 100, then it is a guarantee that I will be able to print all the prime numbers, because chances are that my first 10 prime numbers may not be within 1 to 100. That is also not a certainty, right? It may be it may be within first 500 numbers or maybe first 1000 numbers. I really do not know. In that case, the condition that I'm trying to check here is that I should be able to print 10 prime numbers. Until that condition is met, we should continue to look for new numbers, right? And check whether that number is prime or not. And if that number is prime, then print it and then look for the next set of numbers, whether that is prime or not, till the time you have encountered 10 prime numbers. So, in this kind of a scenario, you really do not know. You know where to start, but you really do not know where to end, right? Do we know? We really don't know. We know for sure that when we encounter or when we have printed all the 10 prime numbers, then we can stop, but then we really do not know what is that number where which is the 10th prime number. Unless we know that for sure, we will not be able to specify this parameter. So for those applications, for is not something which can help you. You can only we can you will only need to use while, and this is one example where you will need to use while. But except for those examples which are a little tricky to deal with, where you do not know when to stop, right? You can specify for loop as well as while loop for simple implementations. Right, guys. So I think with this, I'm kind of done with for and while. We still have a few things to cover in here, which is break and continue statement as well as range function. But I think we can do that next time as well. uh, a few things which we did today, which will definitely require you to do some hands-on and practice, is you need to be able to write logical statements using for and while, and you should be also required to write program codes on your own, which uses conditional statements, if else, and if else if and else. So with this, I'll leave it for you guys to ask questions if you have any. And as promised, I'll be sending across a list of programming questions that you should start solving, and we can discuss them if you have any problems on this Thursday. So do let me know if you have any questions for now. Sure. So we'll meet at 11:30 on Thursday, and that's when we can actually discuss these questions, right? And I'm sure, if you practice and if you do some self-study after these classes, then you should definitely have questions. Yeah. Going forward, yes. Going forward, yes. What we have done so far was very basic, right? And that did not require us to actually do any hands-on. But going forward, we are definitely going to do, the name of the course itself is Python hands-on, right? Unless and until you do the hands-on sessions yourself, uh, you will not get the benefit that you're looking for. So we definitely need to get you, yeah, practice more and more on your own and come back and ask questions. So that is what I'm going to do. It is definitely going to happen. It will be more readily available going forward, but then for today's session, this is going to be available for you by tomorrow. By tomorrow morning, you will have it. All right. Any other questions, guys?